here to focus on a very important topic that has affected lives of millions of children across the globe with its very expensive postnatal treatment. And this has made us think upon whether early prenatal diagnosis of SMA, that is our topic, SMA can open the doors for intensive treatment in future and save millions of innocent lives. And so goes our aim to incorporate early prenatal diagnosis of SMA using early neonatal genetic screening as well as early in utero diagnosis. So what is our aim? Our aim is to divert the attention from being treatment oriented to being diagnosis oriented, from trying to make the cost of Zolgensma affordable for people to making early prenatal diagnosis more common in India unlike other countries. Now before we move further, can any one of you imagine that you and your loved ones are not able to celebrate your second birthday as like the people with critical end-stage spinal muscular atrophy do? Talking about spinal muscular atrophy is an autosomal recessive disease which is caused due to mutation of SMN1 gene, that is the survival motor neuron gene. SMA can be classified into four major types, that is type 1, type 2, type 3 and type 4, of which the type 1 is the end-stage disease. The symptoms of the disease may include floppy or weak muscles, swallowing problems and end-stage breathing difficulties. The number says everything. 1 in 6,000 to 10,000 children are suffering from SMA and 1 in 54 people carry the genetic defect of SMA. 98% of cases, SMA arises from homozygous mutation in the survival motor neuron. What are the problems that we identify? The cost of Zolgensma, which is the one-time only gene therapy treatment for children, is very expensive, that is 16 crores. And if we cannot afford that, then the best we can do is to diagnose SMA at early stage. The gene for SMA has been mapped to chromosome 5q13 where large-scale deletions have been reported. SMN1 exon is homozygously absent in approximately 94% of patients of clinically type 1 SMA. Here we bring about the microcomputed tomography where it was observed under clinical trials on mice that there were anatomical defects in SMA-affected mice, not only in cardiac ventricles but also volumetric quantifications revealed that SMA embryos were significantly smaller than non-affected SMA patients. Now what is PGT and how it helps in early diagnosis? Pre-implantation genetic testing is cutting-edge procedure to identify genetic abnormalities. We are looking into SMA because early clinical trials suggest that treatment should be performed as early as possible. Fetal studies have shown that neopathology starts early in the life and detection of them at early prenatal stage, especially by chorionic villi sampling between 11 to 14 weeks, can help prevent this disease. And there is still time to influence research into SMA so as to ensure researchers focus most on the urgent needs. And at the last, our hypothesis is based on a paper from Edinburgh Medical School, UK, which is presented over here titled Prenatal Manifestation of Systemic Development Abnormalities in Spinal Muscular Atrophy.